Hello friends, so today we will create a car counter. As you can see, this is a preview of it. As soon as the bounding box center pass the line, its the particular vehicle will get counted. As you can see, its left will be 2 and right initially it will be 0. Okay, so this way, let me show you the code. So this is a code which we have. Now I will explain you this whole code line by line, so don't get confused. So let's get started. Before that, let me comment to the extra code so that I can explain you that how the code working is going on. Okay. So these are the libraries which we have to use, and these are the libraries: Ultralytics, YOLO, CV2, NumPy, and from collection we have to import default dict and the DQ. I will explain the reason of it, that why you are using the DQ and default dict. Okay. First of all, we have to load up return model, the model which we are using for the tracking and the car detection or vehicle detection. We are using YOLO11X pre-trained model, and the path of the input video. Let me show you the input video. Okay, so this is our input video for the car counter. Okay, so this is the input video for the car counter which you are using for car counter light. So this is the input image path. First of all, the first thing, or you can say the first step, is that to read the frame of the video one by one. So for that purpose, we have to first make the while loop true, cap.read, and for cap.read pass return the two things, right? Result and the frame. Result means it tells that whether the frame is there or not. If it is not there, we have to break the loop. Otherwise, the frame which we have to resize it according to dimension which we required. The dimension which we required is 1280 to 720. For that purpose, we use the cb2 resize. After getting the frame according to our size, we will show that frame. This is, you can say, the frame name, and we have to pass the frame, and we have to wait for the wait key 1, and as soon as I press Q, it will stop the loading of the frame one by one. After that, we have to release the cap also for the video purpose, and we destroy all the video. So this is the first step which we have to do to read the frame one by one. Let me show you the result of it. It will take time, so wait for it. See, it will read the frame like this. Initially, the frame running is very fast, means FPS is very high because we are not performing any operation over it right now. Okay, so that's why. Now we have to read the as you can see. Let me open one image here. So we have to draw the ROI and line. So how you can see, this is a ROI. See here, this is the ROI blue region. You can see the region of interest which we have, means at this portion only we have to apply the detections. Okay, so let's get started. How to produce this blue region, and also how we have to how to draw this line. So for that purpose, I had let me show the points coordinates value which I have already calculated using the paint software. You can also use the paint software for calculation of these points. Basically, this left side points start from 0, 4, 3, 8, 2, 7, 3, 5, and 4, 8, like this. Uh, like this, 0, 0, 0 means 0, means you can say for the left, 0438 will be the, like this, will be the 0 will be the first point, and this will be the second point, this will be the third point, this will be the fourth point, and this will be the fifth point. So this will be the points I have calculated using the points, you can say, using the paint software. Same way for the right side points, and this is, you can say, left line points, this one and this one, two and points coordinates values are which I have calculated using the print software. So these are the coordinates values. So how we have to draw this region, means this blue region and the lines. Let me tell you how we have drawn it. So let me uncomment it. Okay, now we have to this draw ROI. Here we are just passing the frame. For reason we are passing the left side points, and for the right side we are passing the right side points here. Same way for the line, passing the points only. So let me uncomment the function which we have to require it. See here, this is the two functions which we required. So to draw the ROI range, here we pass the frame and the points which we points also. Then we will make a frame copy, or you can say the overlay. Create the copy of the original frame has so We can draw on it without modifying the original directly. So that's why we make a overlay. After that, we will make a using a fill poly. We will fill that particular region, means fill that particular region, this particular region with the blue color. For that purpose, we use the fill poly. In overlay, we have to fill the colors. In which region? So this will be the points which we are using it, NP array points, and we are converting them into the numpy and in the int format. In which color we have to fill that? This will be the color in through which we have to fill that particular region. So after getting it fill poly, we will make a complete. We will fill that particular region uh, with that color, and after that we have to use this cv2 add weighted function, which give me the you can say transparent region over it. So blend the overlay with ROI, means or with the original frame. It will blend it our overlay with the original frame 0.8 with the with it, and it give me the transparency. It's appear the transparency. For appearing the transparency, we use it. Okay, so it 02.5 is a transparency of a overlay. 0.75 will be the weight of the original frame, and the this create a semi-transparent ROI effect like this. It will create the produce the semi-transparent effect like this. Okay, so that's purpose of use the add weight here. It will give me the we have to pass the overlay and the frame, and the 0.25 will be transparency, and 0.75 will be the original frame weightage. Okay, so this way we'll get a segmented means you can say uh, this type of region being added using this function or draw ROI. Now to draw the line, it's very simple. Just pass the points. It will using the cb2.line. We will just draw the points here. Point 0 means first endpoint. Points 1 will be the second endpoint, and this will be the color through which we have to draw the line. 4 means the thickness will be this. Okay, and it will directly in the frame. So after this, we will get the ROI region with the line. Now let me show the result of it. Let me run it. Okay, as you can see, we get a transparent region, blue transparent region, and a line also. Now we have to apply the tracking. How to apply the tracking? We already load the YOLO model for the tracking purpose. Okay, so here we use this model.track. Okay, model.track, we have to pass the frame in which we have to find the vehicle, or being say we have to track the vehicle. Persist true. What is use of persist true is keep track ID consist across frame. So that's why we use the persist true. Stream true. Stream true means return result as a generator one by one. Useful for processing frame in real time. Save memory. That's why we use the stream will be true. After getting the result, we have to draw the bounding box around the vehicle. Okay. So let's get started. Here we have to in draw bounding box function, we have to pass the frame. Result, basically result is keeping the track ID also, and the bounding box director of the vehicle. Then the left side points, I'll explain you why by passing it. Right side point, and left line points and right line points. Left count and right count. Initially left count or right count are you can say it will be 0. Okay, it will be initially it will be 0 here. Now let me uncomment the function draw bounding box, or you can say this is our main function, or you can say the core of our project. Okay, so let's get started. We have to pass the frame result which we get through the YOLO detection. Left points, right points means the polygon points, or you can say region points. Left line points, right line points. Left count or right count initially it will be 0. Now we have to make we are have to call we also have to call this cross left side and cross right side, means the point which have crossed the, or in this case we have vehicles which have crossed the left region or right region. For that purpose we have to make two things. Using the set, we have make it to store the coordinates value or the center point or the vehicle which have passed the left side or the right side. Or you can say we are using left ID, means we have to store the track ID. Now we have to loop over the result. After getting the loop over the result, we have to loop over the r dot boxes, that boxes. If the box id is none, we have to continue. Otherwise, if the box id is there, then we have to store the particular box id in a track id. After that, means we have to get the bounding box detail. To get the bounding box detail, we have to use this map int. First of all, this box x by x by means x1 y1 x2 y2 coordinate. In this form, we want to get the information of the bounding box. After that, we have to convert those values into the int. After that, we have to map all these values with x1 y1 and x2 y2. So this line is working. After that, we have to calculate the row center. What is this row center? Row center is basically the center of the bounding box. Okay, this is a row center which we have calculated to, or you can see the x center and y center of that particular bounding box. For the calculation of this, which we are how we are doing it, first of all, x1 plus x2 divided by 2, same thing, y1 plus y2 divided by 2. This give me the row center coordinates value, x center y center coordinates value. After that, you can see, you have seen this is a center value. This is not a perfect bounding box center value. These are the smooth, we are representing the smooth center here. What is the use of this smooth center value, and why I am calculating the smooth center here? What is the use of it? Let me explain you. For that purpose, here we are passing the track id and the row center. We are passing the row center and a track id. So let me come back to the function which we are using it. So this is a function. So this will be the function which we are using it for the get a smooth center. Basically, get a smooth center in which we are using the center history. Okay, so this will be the center history. So what does center history basically do? Here we are using the center history default dict lambda dq max line 5. What it's mean? Let me read this two line. Dictionary that auto create a new entry for any new id where each entry store only the last 5 center position for the that particular track id. Means it stored that particular track id last 5 frame center coordinates value. Why it is useful? It give me useful to calculate the average row center, or average center position value, not row center position value. And also it helped me to avoid the multiple counting of the vehicle. Okay, and also you can say it's very useful. Now let me show you why this smooth center avoid the multiple counting. First of all, let me explain you. Suppose in this particular frame, this vehicle center value is here, but in the next frame this center value will come to here, but again in the third frame it's come here, and again in fourth frame it's come here. This way multiple counting of the vehicle will come, and it will destroy our counting. Okay, or we can say destroy disturb the counting of the vehicle. So to avoid this, I am using one method, get smooth center. In this first of all, I required the last 5 frame particular track id, last 5 frame you can see this center position value. And also here I am calculating the average x and average y, which help me to avoid the you can say multiple counting of the vehicle. So first of all, let me explain this whole function here. So this will be the function. So here after getting the, you can say center history, after using the track id, which using the track id only, it will store the center position value. So first of all, after I'm getting the new center here of the particular track id or you can say row center value, we'll append that in the center history. Okay, now let me go back to the main function. Okay, new center, here we passing the new center only now. Yes, row center is act as a new center here only. Okay, so let me come back to here. So after getting the new center, we will append that into the center history, which is store the last 5 frame particular track id points. So let's show the example. So this will be the coordinates value, center position value for the particular track id. And when I will use this center list center history track id, it give me the list of it into center format. It give me the list like this. Okay, after getting the list means the list look like this here. After getting the center position value, after that I want to extract all x, or you can say I want to extract all x here. So for extracting the all x, I have to use iterate over the for c in center. All the c0 will be my x. So which I append the in x append x means here. So this way I get the all x here. This way I got the all y here. After getting the all x and all y, I will make the sum of both xx and xy. After getting the sum, I will count the length of the center. Okay, count how many frame we have stored. So we have count means we have 5 frame, last 5 frame, particular track ID, last frame. So to get the average, we just use average x divided by 5, total x divided by 5, total divided by 5. So this way I get a you can say a smooth x and smooth y, and you might be possible that it will be in a float value. So I will convert them into the int way. So this way I get a smooth x and smooth y, or you can say the smooth center, it return the smooth center. And how it's avoid the you can say multiple counting. For example, for a particular track ID, let me talk about the first track ID, and you already know that my line, where is my line coordinates value? Suppose I'm talking about the left, my line coordinates value, y value will be 334, and why only we are using the y for, because y coordinates value will decide that the vehicle has crossed the line or not, or there will be the multiple counting of the particular value on particular vehicle or not. X coordinate value will not affect anything. Okay, y coordinates value will always affect for the multiple counting. So at that purpose only, we have here we are using the y coordinates value only, so don't get confused here. Okay, first of all, in the first frame, if the y coordinate value is 320 and my line y value will be 334, 320 means it has not crossed the line, means above. In the second frame, I got the frame 336, means above the line or below. It means it has it has count. It means it has crossed the line. It's above the line, means it's saying that it has crossed the line. So we have count that particular vehicle one. And in third frame, its value will be new y value will be 332, means just you can say it's above the line. So it's move again back to the line, and again when it's come to 338 in the fourth frame, it means it has crossed the line. So multiple counting of that particular vehicle has performed here, and it disturbed the our left side counting vehicle. So this way to this way it's affected. So if when I will use this average here, you can see when I will use this average, it's continuously value will increase. Okay, it's not affecting my multiple counting. Okay, it's not affect my multiple counting, and we only count the vehicle one time only. So this way it's after getting the average y, or calculation of average y coordinate for the particular vehicle coordinates value, it helped me to avoid the multiple counting. I hope I make the clear how the smooth center value avoid the multiple counting. Okay, then after getting the smooth center value coordinates value written out smooth center value, we have to check that the smooth center is lie on this left region or in a right region. Why? Because we want to know that particular vehicle has crossed the left line or a right line. For that purpose, to get that the particular points is on a left region or right region, we have to use this function CV2 point polygon test, where we pass the left polygon region points value like this one, x1 y1 x2 y2 region, and we pass this row center here. What is user false means means measure distance false. We only care about the inside outside, not distance. So this way it's false, and it's basically till here. After passing the polygon points and the center value to know that the point is in a which region, left region, right region, it returns three value will be returned. Minus plus one means point is inside the polygon, 0 point is on the edge, minus 1 point is outside the polygon. So we require this truth statement, means if it is greater than 0, okay, greater than or equal to 0, means we consider it that particular point is inside the in that particular region. Okay, so this is a way we will decide that that a particular point is in left region or a right region, and same way the calculation is going on here. After it, circle color, my default the color circle, you can see default color will be yellow. As soon as the center is on this line, its color changes to purple. Let me show you that Now after, if it in a left region, if it is a left region, we also want to consider it that a particular track id is already past the line or not. So how we have to consider it? For that purpose, we already make this, you have seen that, we have made this cross left side id. You can say cross left id means we have to make the list, or you can list that particular track id has passed or not. In this particular list, we have to check that particular track id is there or not. For that purpose, if the track id not in this, it means it has not crossed the line, and it will move inside the if statement of it. Then we have to find that particular track id is crossing the line or not. For that purpose, we use this function if point crossing line. We have to pass the center, then the left line, one side endpoint, and right side endpoint, and we just move to the if point crossing line. So let me go up. So this will be the function we are using for calculation that particular center value has crossed the line or not. Let me go to the help function. Okay. So here we passing. Let me show you what we are passing here. See, here we're passing the center value, the smooth center which we have getting it, average center's coordinates value, left points and right points coordinates value, right? This much we are passing it. After getting this, what this function do? The function check if the object center close enough to the line. If yes, we say it's touching or crossing the line. Okay, so how? First of all, point cx and precise center points, line point 1, first point of the line, and second point of the line. Okay, threshold, how close the point should be considered. Default value will be 4. 4 is, you can say, 4 pixel value. How close the point should be to consider it online. Okay, how close? If suppose the you can say, if suppose the center value, if suppose the center value is nearest to the 4 pixel value of this line, we consider it at crossing the line. Okay, so this is I believe the threshold meaning. Okay, now after getting it, cx, cy, expanded y to y2 value, then step 1, create line equation. We convert the line into the mathematical form, means ax by plus c0. So this will be make it the a, v and c. After making it, it helps us to calculate the distance of any point from the line. Now we have to calculate the distance of that particular line, or you can say particular point from the line. Okay, how we have to calculate this? For that purpose, we use this distance formula. We find how far the object center is from the line. For the calculation of this, we use this formula. Okay, I will use this formula to calculate how far the object center is from the line. After that, if the distance is small, points is very close to the line. This way it's work. Now we have to check the boundary, means which is important. Every point is close to the line, but we must check if the line between is the two endpoints, whether it's the point, whether the point is line between the two endpoints. So for the calculation of that, we use this calculation here, which give me on segment or on segment coordinates value. Okay, for the x and y. After calculation of on segment value, we have to avoid detecting points outside the actual line points of segment. So after calculation of this, we use this. This will be the you can say, first of all, we check point is close enough to the line using the distance. Now second check will be make points lie within the line segment. We have to check it. For that purpose only, we have calculated the on segment. After that, when we say object is touching the line, when the distance is the distance of which we have calculated here is less than equals to threshold also, and also with less than equal to the on segment, then we say that the particular point has crossed the line or not. Okay, so this way we are doing the calculation for the is point crossing the line. If it has crossed the line, it will be true. Then we move inside the left if statement. Then we have to update the left count will be +1, and also we have to pass the we have to update this cross left add id. Here we have passed the track id, that particular track id has crossed the line. And also when circle color will become to purple, means when this particular circle is on this line, the purple color will be reflected. Okay, then same way for the right reasons, everything will be the same. Now CB2 rectangle, what is this rectangle here? Let me show you. Draw a bounding box, means now till here we are moving in this for loop. So this is working for the, let me talk about the for the first vehicle only. It's working. Everything is working for the first vehicle. To draw the bounding box on the first vehicle, why how we do draw it? For that purpose, we use the CB2 rectangle. Just pass the frame. The x1, y1 coordinates value will be the top left corner coordinates of the bounding box value. X2, y2 will be the bottom right corner coordinates value of the bounding box. This will be the color, means through which we display the bounding box color. Then this will be the, you can say, the thickness of the bounding box. Then we have to draw the circle. The circle means this one, and here we are drawing the smooth center. So as you can see, we are passing the we are drawing the row center here. Okay, or it might be we can also draw the we want to draw, we do not want to draw the row center, we want to draw the smooth center. Okay, which is more good. Sorry, not the smooth center, it will be the center only. I am right? Yes, yes. Smooth center is have a variable center here. Okay. Now center color radius will be 4. Circle color will be that, by default it is yellow, but as soon as it's on a line, the color will be changed to purple. -1 means we will fill that particular circle. Now we have to put the text, means the track ID. You have seen this. Every vehicle has its own track ID. So to display that track ID, we will use frame, and this will be the thing, or the string which we want to display, and this will be the you can say the coordinates value for the text. This will be the font, this will be the scale 0.7, the color, and the thickness. So this will be display the track ID. After that, at the end, it will return me the frame. This, after all this rectangle draw and everything, it passed me the frame, left return left count and the right count. After getting the left count and right count, I want to display this text also, left 0 and right 0. So how I want to display it? It's very simple, just 2-line statement to put the text here. Okay, put text, string will be left, just pass the left count. Okay, then you can say this is the coordinates value which already have calculated, that through which we have to display it. This will be the font, 1.2 will be the scale, color, thickness, and same before the right, 950 I already calculated it, font color. So this way we actually count the vehicle from the left to the left side and right side. I hope I make everything clarity. Now let me run this whole code and see the result of it. Okay. It will take time because I am not using the GPU, I'm using a CPU. Okay, so don't worry. As you can see that I'm using the CPU, so the bounding box coordinate value and the frame reading frame is very slow. Okay, as you can see, as soon as this vehicle will pass the line, purple color will also display and left count will become 1. Okay, so you can see it. It's moving very slow because right now I'm using the CPU, not a GPU. Okay, so forget about it. Okay, see, left count become 1. Okay. It's working very slow. Now let me I already already download the you can say whole video I have downloaded in an output format. So let me show you the result of that. Okay, let me close this. Now let me show you the output video. Directly I will show you the output video, which will make you more clear how it's the code is working. So this way you can see this, the as soon as the vehicle, this vehicle will pass, this vehicle will pass the line, you can see purple color display, and also left count will become 1. And same way, this way 3 vehicle has crossed the line. And for the see, now for on the right side you can see when as soon as this vehicle will cross the line, it will become 1 here, you can see it. Same way 4, 5, 6. Okay, here right side, second, third, and fourth, and see here it's become to 7 now. So this way the our car counter is working. Hope you understand well, and forget that I'm not using the GPU and using a CPU. Forget about it. So if you gain something from my explanation, I have explained you each and everything line by line. Explain the user of that, how we are checking the crossing line, how I check the, I'm using the smooth center here. Hope you have gained something from my video. So please like, share, and subscribe my channel. Thanks to all.